So sometimes, in fact, frequently, you aren't going to know how many times you want to do something when you're getting input from the user. So what we typically do to handle that is use a Sentinel value. So let's take a look at that test score program we just did and how we could change that so that we can signify to the computer when the user is done entering values. We would create a Sentinel value, which is sometimes called a flag, to explain that we are at the end of doing our data entry. So what I'm going to set is I'm going to set our initial value, which we're going to replace, and it will be equal to 1. So we're going to have a variable, and I'm going to call the variable done. I'm going to set it equal to 1, which is an integer. And then we're going to do a while loop. While done not 0. So as long as it's not 0, we're going to keep going. We will provide, and we should actually do this before the loop. We should do a print statement. Print enter 0 when you are done. Because you want to tell the user how to use the program. So we can ask it for how many, we're going to ask it for whatever the test score is. So we can do, and so we'll need some other variables, which I'm going to just put over here for right now. So we're going to need a variable of count, and that count would come first, and it would be initially set to 0. And I'm just going to put the variables all together to make it clearer. So these would come for me at the beginning of the program. So we're going to have our variables here. So we'll have count equals 0. And order of the variables that they're declared in doesn't matter as long as they're declared before we use them. We're going to have done equals 1. And we're going to have total equals 0. So those are the 3 variables that we're going to use in this program. So we're going to, before we enter our while loop, have them know that they need to enter 0 when they're done. And while done is not equal to 0, then we will have value or score. I think score is actually clearer. Score equals int, because it's coming in as a string. Enter test score. Now we're actually starting with 0 here, so we're going to need to do a few things. We're going to do count, which starts at 0, plus equals 1. So counter equals itself plus 1. So counter has now moved from 0 to 1 on our first trip through. Then we're going to do total plus equals score. And so let's look through the logic of this as a user is going through. So this will print on screen. Enter 0 when you're done. While done not equals 0. Currently, done is 1. So we're going to go enter the while loop. Score equals int, enter the test score. And this is called desk checking. I'm checking my logic because I might have an error in here. In fact, I just realized that I do. So score equals enter the first test score, and we'll say that score equals 85. Count plus equals 1. So count is now equal to 1. Total plus equals score. So total is now equal to 85. But if I don't do anything else, this becomes an infinite loop because I'm not doing anything to change the value of done. So here, I need to add in an if statement. And it should go right here. If, nope, it should go right when they get the test score in. So these would move down. This is easier on a computer when you forget a line and need to go back, but something that happens commonly. So here we do if score equals 0, done equals 0. And that should be tabbed in. And then we can go back to total plus equals score, and count plus equals 1. And so this gives us a way to end the loop. And it's really common to make the mistake that I just made here. So you should get in the habit of reading through your code, working through the logic first before you run it. But if you just run it, you'll get an error because it will ask you and it will never stop, and you'll get that it's a endless loop. Really common error. So if we're doing the logic, we'll run through it again. So done starts with 1. Count starts with 0. Total starts with 0. So first thing we do, enter 0 when you're done. Great. Well, done not equal to 0. Done's 1. Score equals a test score. So we'll say that they put in 85. So score is now equal to 85, which is not 0. I have an error here because these should not be in my if statement. So what actually happens here, this is tabbed in, we want to make sure they're actually directly under the if statement, because anything tabbed in would be part of it. So we're watching for those errors too. So then we'd have total plus equals score and count plus equals 1. Okay, so let's go through that logic again. And here I am looking for my errors. So this is indented. So it will check to see if it's done, then it will drop back into my logic here. This is all part of the while loop. So we have a decision statement inside our while loop, very common. So the first time through, enter your score, 85. If score equals 0, that didn't happen. Total plus equals score. Total is now 85. Count plus equals 1. Count is now 1. So the second time through, we're going to say it equals 100. So count is, well, we'll do it in order. So this is going to equal, total is going to be 185, and count will now equal 2. And we could keep going that way. And that, so we'll say 5th, 6th, whatever that we're at. They enter 0. At that point, 0 and adding 0 to, that could cause us a problem with count, except we started with 0. So you're going to actually have to check that to make sure that we're getting the right count. So there's all sorts of hang-ups that we can get in the logic here. So because we want to make sure your count is your real count, and we'd test that since we're starting with 0 and doing it 1 each time, because these will run regardless of what was entered here. So you've got to sometimes check your order on those. So you're going to do multiple iterations of most programs where you could be doing this logically, or you could just run it and see what happens. But you've got to check your logic and make sure each thing is happening correctly. And this is sort of the process you would go through in writing your program where you have indentation errors and other errors. And you check it against values that you can do yourself to manually check it to make sure it makes sense. One of the things that I would typically do would have a print statement. So I'm seeing what number we're on. And then I delete it in the final run of the program, but I like to have a print statement showing me how my variables are changing as I work. But there's other ways you can track that too with debugging that we'll get to in a computer demonstration.